Hello friends. In this video, we are going to see simple motor control circuits, which is a two-wire controls, which is very commonly used for few domestic applications and few industrial applications as well. So here we have only a two-wire which is connected from the motor to the control circuit. So that's why we call this as a two-wire controls. Mostly this kind of controls can be used in automatic operation of a compressor, heater, and air conditioner, refrigerator kind of systems. So let us see a few example of this, and also we will see the ladder logic for the said system. So as I said, these applications can be, this type of controls can be used in sump pumps, tank pumps, electric heating, and air compressors. And let us see one example of it. So here the first example is about the compressor system, where you have a main control MCB or fused contacts, and we have a transformer to give a supply to the control circuit, and this control circuit is controlled by pressure switch. The motor is getting connected and disconnected to the supply with the help of contactor contacts, and these contactor contacts are going to be activated or deactivated with the help of contactor coil, which is connected in the control circuit. So now when the pressure settings of this pressure switch, so you may have the lower limit and then upper limit. So when the pressure is reaching to the lower limit, the pressure switch is going to close the circuit of the control circuit. So when the control circuit is closed, the main contactor is going to energized. So when the contactor is energized, so the contacts is going to be closed here. So when the contacts are getting closed, so the motor is going to run, so that the compressor is going to create a pressure in the reservoir. And when the pressure is increasing, the same pressure switch is going to monitor the pressure, and when it reaches to upper limit, so the pressure switch will open and the main contactor is getting de-energized. So because of this, the main contacts will be opened like this. So when it is opened, then automatically the compressor goes off, and when the pressure is again reaches to the lower limit, the operation continues in the same manner. So the wiring diagram of the above said system is given here. So here we can see the fused contacts here, and from here we have a contactor contacts, and for the control system, through the control transformer, it goes to the pressure switch here. So the pressure switch is monitoring the pressure of the reservoir in the compressor. So when the pressure reaches to lower limit, the pressure switch is going to close. So the circuit will be closed through the main contactor coil, and it goes back like this. So when the main contactor coil is energized, the contacts will be closed. So the power supply will be given to the motor. So the motor will run, so that the compressor will be running, and it will produce the compressed air, and you will have the pressure in the reservoir. So because of this, the pressure will slowly get increased. When it reaches to certain point, the pressure switch will open the circuit, so that again the pressure will be maintained. When the load is consuming the air from this reservoir, so automatically the pressure will be dropped in the reservoir. So because of this pressure drop, again the pressure switch will switch on the system. So this operation goes on until otherwise you open the circuit from the fused disconnect. So we don't have any latching system here. Based on one particular physical condition, the circuit is getting closed and opened automatically. So this kind of system is called as a two-wire controls. This very simple mechanism you can see in your refrigerators and air conditioners in your home. So you may set a temperature in the air conditioner, say for example 20 degrees Celsius or 25 degrees Celsius, and when the main supply is switched on, then automatically the air conditioner getting on based on the temperature of the room, and when the temperature reaches to set point, then it will switch it off automatically. And because of this condition, again the temperature will slowly increase again at a certain temperature, then the compressor or this air conditioner will get on. So this is a very simple application which we usually see in our day-to-day life. Another simple example of a two-wire control system is a water control or a liquid level control in a tank. So let us assume you have a water inlet from here, which may be from another tank or maybe from the motor. Okay, so we have a continuous water flow, and here we have one more pump which is taking the water from here, giving to the another tank or another system. So we are not talking about this pump. We are going to control this motor or this pump. So let us assume that there is a water flow continuously here. So we are going to fix a float sensor at this point, float sensor at this point. So when the water rises to this limit, what happens? When the water rises to this limit, the float switch will get closed like this. So because of this, then the main contactor here will get energized. So because of this, what happens here, the contacts of the main contact will be closed, and because of that, this motor is going to be energized. And when the motor is energized, so it is coupled with the pump, so the pump will be taking the water from here and taking to the next system. So when you are taking the water from here, so the water level will slowly decrease. So when it is decreased to certain point, the float sensor will open the circuit here like this. When it is opening, so again this motor will be off. So when this motor is off, so that the water flow is available here, so slowly again it will reach to the upper limit of this float switch. So again it will close, again the contactor will get energized, again the motor will be on. So this process also continuously takes place until otherwise you turn off the main power to the total system. So again this is another simple example of a two-wire control. So the two-wire controls can be with multiple sensors. So this is a simple example of a boiler controller. So you may have a boiler, you have a liquid level measurement or liquid level control for this boiler. So you need to have a lower limit and upper limit liquid level, and also we need to have a minimum temperature of a thermostat which it has to start, and the high temperature at which the boiler or a furnace should get off. Okay, so here we have a thermostat which controls the uh, you know total operation. So this is a minimum limit. So when the minimum limit of the water is available, so here the minimum level, so here this float sensor, when the minimum level of water is available and the temperature reaches to certain point, okay, and the system gets on, the motor gets on, and we have not shown the furnace here. So the furnace we are not controlling, we are controlling only the pump which takes out the water from the boiler to the next stage. Let us assume again here the water is coming in continuously, and we have a motor or a pump which takes out the water from the boiler to the next stage. And this we are going to monitor different conditions, the minimum temperature and minimum level of water. And in case if the water flow is more here and if it reaches to higher limit, then the system will open the contact so that the system will get off, until otherwise the water decreases to the allowed limit. And also when the temperature rise to higher limit, again the system, the furnace will get off so that the boiler temperature will be maintained. So we have four different conditions. So these two are NO type switches and these two are NC type switches. So when it is reaching to this limit, it will break the contact and it will stop the system, and when it is reaching to these particular limits, so these two will close the contact and it will enable the system to get on. So again, so though we have four different sensors and four different controls, again we don't have any latching mechanism, automatically it gets on and get off, so once you power on the motor or a pump. So this is a two-wire control. Let us see the ladder for this particular application in the PLC. So this is the ladder for the the said program. So I'm going to show you how this is going to work. Okay. So I have four sensors which I have represented in the control circuit. So which I have put here in the ladder as well. So I'm going to set on. So we have, as I told you here, we have low minimum water level. So the water should fill at least to certain point. So this will close automatically. So let us assume the water reached to minimum level. So this is getting on, and these two is normally closed switches. So it is already closed. And here the temperature again, if it reaches to minimum limit, then the boiler output will, the motor which will take the water from the boiler will enable. So this coil is getting enabled, and the water is getting going to the next level, or to the next stage. In case if the water level decreases to certain extent, so this contact will open, and when it is open, then automatically system will go off. Or if the temperature reaches to higher limit, so then this particular contact will enable. So like this. So what will happen? The motor will go off. Or in case if you know the limit, water limit reaches to certain point again, so this can go off. So that condition, so this is a AND gate condition. So if any one of the condition fails, then automatically the motor should go off. So there is no latching method. So this is based on, purely based on the physical conditions. So these kind of systems are called as two wire control system.